Hello guys, welcome to this series of basic power system. So today the topic of this lecture video is system voltage and transmission line. Okay, number 6 topic. System voltage and transmission efficiency. We have already covered those five topics in previous videos. So let's start. So system voltage refers to the voltage level at which electrical power is generated, transmitted and distributed in a power system. So what it means by system voltage? System voltage means the voltage at which electrical power is generated, transmitted and distributed in a power system. Okay. So power system typically have different voltage level for generation as well as for transmission and for distribution also. Means for generation there is different types, different level of voltage, and in transmission there is different level of voltage. Means suppose it's 1 volt, it can be 2 volt, it can be distribution can be 3 volts, like that. I'm just example showing. Okay. It is not compulsory that if we generate suppose 5 volt, it will distribute only 5 volts. It's not like that. So voltage level in power system, we'll see here at the generation typically range from 11 kilovolt to 25 kilovolt. Means at the generation station. Okay. Where we generate at that time, we typically generate 11 kV to, means this is the range. Okay, normally. And for transmission, we normally transmit in higher level of voltage. Okay, to reduce loss. So high voltage levels usually between 110 kilovolts and 765 kilovolts. Okay, this is the range between. It can be like according their requirements. Power system they pick their uh, voltage level and are used to transmit power over long distance and to reduce loss. Okay, high voltage for long distance and to reduce loss. Distribution, I think you already know this parts: generation, transmission, distribution, or utilization part of the power system or the transmission system. For distribution voltage, lower voltage level where we distribute to the customers. That level is 11 kilovolt to 33 kilovolt. Okay, this is we can see our nearby area. They are used to distribute power to consumers. Okay, and utilization voltage, the voltage at which end user consume power. Usually 230 volt. At our home we use usually 230 volt. Okay, for single phase and 400 volt for three phase systems in many countries. Here we especially mainly use 230 volt in India. Importance of high voltage in transmission. So why it is important to transmit in high voltage level? First one is reduce current. So high voltage reduces the current for the same power level. According to, we know P is equal to V by, sorry, V into I. Sorry, it will be, it will be P. Sorry. P, we know P is equal to V into I. Okay, we know that one. So we are keeping the P constant. We are keeping P constant. Okay. By keeping P constant means power we are keeping constant, and we are uh, reducing the current value P into I. We are reducing this one. Okay. We are reducing the current value. So automatically to keep this power P, we have to increase the voltage. Okay. You got it? We are keeping P constant, power constant, and we are reducing current. So we have to increase voltage to keep to maintain that value of P. So lower lower losses reduce current ends to lower I square R losses. We know the loss. This loss is I square R. So when we are decreasing or reducing the value of I, that means loss will also decrease. Okay, because in loss calculation that is I square R. Yeah, I think you know. And improve efficiency. Higher voltage improve overall transmission efficiency by minimizing energy loss, because it's minimizing the energy loss. So it's increasing the efficiency automatically. So because of all these things, we need to high voltage. We need to transmit in high voltage. Okay, transmission we need to do in high level of voltage. So suppose consider a three-phase system, and all the values here: P power to be transmitted per phase, voltage V is equal to voltage per phase. So plus cos theta is equal to the power factor of load. So active or real power per phase is, okay, I'm not going through all this point. Okay. So active power or real power per phase will be P is equal to VI cos theta. So from here we can calculate I is equal to P by V cos theta. Okay. So current density J is equal to I by A. So A can be P by J. We'll just put the value of J here, J A cos theta. Resistance of conductor is R is equal to rho L by A. We know this one. All these are equations actually. So you have to keep, you have to remember all those equations. Okay. You just put the value, and this is the resistance of conductor. So I'm just putting all those things because maybe you guys need this for simple basic numerical problems. So real power loss actually is the power loss in the line per phase is P denoted by PL. That loss is I square R. Here again the same values are replaced. If P by V cos theta, and PL is equal to, it will come like that, J rho LP by V cos theta. So from here we can write that, so the power loss in the line is inversely proportional to both the system voltage and power factor, because this is power loss PL and V cos theta. V is voltage, cos theta is the power factor here. Cos theta is power factor, V is the voltage. Okay. So from this equation we can say is the power loss is inversely proportional because it's downside. Okay. Power loss is inversely proportional to both system voltage and the power factor. So this is the relation of voltage with the power. Okay. The power loss. Actually, all these are calculation part. Then transmission efficiency. The efficiency of transmission is denoted by Nt. It's tau. Is so it is actually efficiency of transmission is line output by line output plus line loss. So line output plus line loss, that means what it is? It is the input line input, we can say, na? Because from the line input actually line output is coming, and there are some line losses. So this total is line input. That's why here directly it is written as P out by P in into 100%. Okay, for calculation of 100, for calculation in percentage, yeah, you have to just remember this line output efficiency of transmission line is line output by line input plus line loss, or line output by line input. Okay, these are all calculation parts if you want to go through. So P by, again, those P value line loss calculated in the previous slide. Okay, from here it will finally kind of come like this, and by neglecting higher order and by binomial theorem using, it will become like this. We need this equation in solving problems. From this equation, we can say the efficiency of transmission increases with increase of supply voltage and power factor. Okay, so factor affecting transmission efficiency. I'm not going so much in details with those uh, calculations part. Okay, if you want in details for all the calculations, you can comment in the comment box. Maybe in advanced power system series, I'll try to cover all those things. Okay. So factor affecting transmission efficiency, conductor resistance. Higher resistance lead to greater power loss. You know, because resistance, what is resistance? It resists the flow of current. That means there will be loss. If the higher resistance conductor has, that means more loss. Then line length. Longer transmission lines have higher resistance and more losses. When the length is more, that means resistance also more. When the length is small, that means because it has the where the transmission line has some resistance already. Okay, and the power factor lower power factor increases current and losses. Line voltage, higher voltage reduces current and losses. Higher voltage, we have seen the relation. If higher voltage, that means the P is equal to V into I. If higher voltage, that means low current, that means I square R, this is the loss. Loss will be less. Okay. Load distribution, even distribution of loads across space improves efficiency. If there are loads are not even not distributed nicely, it can increase like uh, the loss. That means it will reduce the efficiency. That means that there are different types of load, linear, non-linear loads are there. We'll cover those things in the topics. So calculating transmission loss, as per the same thing we have said here earlier. I square R is the loss. Okay. So P loss is equal to I square R, where the current I, sorry, where I is the current equal R. R is the resistance of the transmission line, and power delivered is the power generated minus P loss. So this is loss from the total power. Total power is the power generated. So that power will be delivered. Simple equations. Not it's actually not equation. It's just concept. Okay. This is power loss. This is power generated. So the rest part is delivered. This part of power is delivered. Voltage regulation. Voltage regulation refers to the change in voltage magnitude as the voltage varies from no load to full load condition. Okay, voltage regulation refers to the change in voltage magnitude. Okay, change in voltage magnitude as the load varies from no load to full load conditions. At first, no load, then when it becomes full load, between this duration, the voltage magnitude changes. That is called voltage regulations. Okay. So voltage regulation is equal to V no load minus V full load by V full load, and for percentage 100. Okay. Importance of this voltage regulation is good voltage regulation ensures stable and reliable power supply to consumers. So transmission line or the power system must need to be have good voltage regulation value. Okay. Voltage regulation value is the V no load minus V full load by V full load. Methods to improve transmission efficiency. So, or what are the things we can do to improve the transmission efficiency of power system or transmission system? High voltage transmission using higher voltage level to reduce current and loss. We already discussed. Capacitor and reactor improve power factor and reduce losses. Okay, we need to improve power factor and to reduce the loss. HVDC transmissions, high voltage direct current transmission reduce loss over long distance and improve efficiency. And advanced conductors using conductors with lower resistance like aluminum alloy conductors or conductors. These are like they have lower resistance compared to other conductors. So this can be the methods to improve transmission efficiency or to reduce loss. So that's it, guys, for this power system voltage and transmission efficiency topic. I'm just going through basic parts, okay, of power system only, and we are covering these topics also very basic things. Okay, we'll come later with the advanced power system. Before starting or before going to advanced power system, we must need to get some idea, basic idea, so that we are getting from this lecture. So if you have any doubts, you can comment in the comment box. And I'd like to request you to subscribe this channel. And my humble request to you guys, please just plant only one tree in a week or in each Sunday. Okay. I think the only way to fight against global warming is to plant trees. So that's why we must need to do planting. Okay, plant trees. And this PPT is available. If you want to keep it as note, you can request me. Okay, to this email ID. And in the next lecture, we'll cover the comparison of conductor cost of transmission system. Okay, so bye bye, guys. Enjoy.